As we finish up Unit 2, which there was quite a bit to it, we still have a few more things to do, and this is where, with the word problems, we need to know how to use our calculators a little bit. So, earlier, plenty of problems where we were being told we didn't know. That's one of the big keys, everybody, I should say. We didn't know angle theta. Look at all those earlier problems. You were given a right triangle, theta was somewhere, or you were given a trig value at theta, and then we made a right triangle, but we never established what theta was. Now, we'll know what our angle is, but also just look at these two problems I have here. There are rounding directions. I don't have a problem yet. I really just have the directions, I should say, but they both include rounding instructions. That should be very, very clear to make it, that should be a very clear-cut point to say, okay, I need my calculator for at least something here. And for these problems, that's going to be the entirety of it. So number one, I'm going to start off with, what is sine of 112.6 degrees? All I need to do that is turn my calculator on. Again, I've got two here. You may have a slight difference, but most are pretty similar to one of these two. I've got my sine, cosine, tangent button here. I've got my sine, cosine, tangent button here. But before you do any trig, check your mode. Right now in radian mode, that's in degrees. So here, go to degrees. That's it on this one. And now I could enter sine 112.6. Close parenthesis or not, that's not a big trouble here. It's a good habit to get into. Enter. And now again, round to the third decimal. So look at the fourth. This would give me 0.923. Right? If that was 0.9235 or 7, that would round up to a 4. But 4 or lower, we cut it off and leave that as a 3. No big difference on this one. Mode, still in radian. So go over, put myself in degree. Now I can quit. Sine 112.6. And of course, we get the same thing. Just that easy. Number two. Well, that's fine and dandy if we're dealing with sine, cosine, or tangent. But what if we are asked for secant of 306 degrees? Doesn't matter which calculator, they're both already in degree mode. I just have to still remember the fact that secant is 1 over cosine. There is no secant, cosecant, cotangent button. You're always going to have to do that for yourself, and that's all there is to it. 1 divided by cosine 306, enter. Again, looking here to round here, and I would get 1.701. Number 3, let's do two more here. Number 3, let's look at cosine of 7 pi, let's do 2 pi over 9. Cosine of 2 pi over 9. Well, the big difference is now I'm in radians. So either calculator, well, I guess you have two options here. You could take a moment to convert 2 pi over 9 into degrees. It's 40 degrees. And then just leave your calculator in degree mode and do cosine of 40. Perfectly fine. But since all we're doing here is trying to use our calculator, why not just use radian mode? Switch to radian mode. And now I'll do cosine 2 pi divided by 9. This one I won't change. I'll leave in degree mode. But again, I did it in my head. And no surprise, we get the same thing. Third decimal. So we get 0.766 for this one. I'm sure we'll get something that has to round up. Just so far, just a coincidence, right? I'm not cutting off every single time, every problem that I've used the calculator so far, always rounding. That's such an important thing. Okay, last one here, number 4. How about cotangent of, let's do 7 pi over 5. This one's already in radian mode, so I'll just use this one. But it's cotangent So I'm going to have to enter 1 divided by tangent 7 pi divided by 5. And here, now we finally get to round up. 0.3249, that rounds up to 0.325. So that's the first thing. Just being able, looking at the angle, degree or radians, using the right button to then just get the right decimal approximate. But now notice, now in the second part, now I am asking you to go backwards a little bit. All of these were trig functions of an angle. We're getting decimals, but that decimal still represents that ratio of sides inside a right triangle. But now we're trying to go backwards. So let me first give you a problem. I'm asking you to find theta. Let's find theta given sine of theta is 0.25. This is where we need the inverse trig. That's the sine inverse, cosine inverse, that -1 over it. And again, pretty much the same on all calculators. Wherever your sine, cosine, tangent, you've got the inverses right above. And that's what those functions do. Regular trig functions, you input an angle, you output a value. The inverse trig functions, you input a value, and the answer you get is an angle. And we are going to do a little bit of that here, not a ton. And there's a lot more inverse properties that we could discuss, but all that stuff comes up for any of you who go into pre-calculus. You get a lot more information about these inverses. But that's the big idea. So that's all we have to do. You start with this. Well, how do you find theta? You do this on your calculator. But now my units, well, let's make sure we're in degree mode because we're being told in degree. Now to the nearest, I should be even more clear, the nearest whole degree, the nearest tenth of a degree, just like up here. I could easily ask you to round to the second decimal place or the fourth decimal place. So just make sure it's not always to the third. That just was all I asked for here. In this one, it's not always to the nearest whole degree. It might be to the nearest tenth of a degree, to the nearest hundredth of a degree, so the second decimal place. So just follow your directions. But now we definitely have to make sure we're back in degree mode because that's what it says. But now I just do the second. Notice that's not sine, that's the inverse sine. 14.4. So that would be 14 degrees. This is an excellent example of be careful and don't double round. People, remember, if you're going to round to the nearest whole number, well, you're going to look at the first decimal. You always go one past, but don't double round. And what I mean by that, people go, oh, well, this is a 7, so this 7 should round this up to a 5, and now this is a 5, this is round up to 15. That's 2 rounding, just 1. That's a 4, 4 and below, we cut off. That's why the answer is just 14 degrees. That's it. And let's just do one more. What if I had cosine of theta was 2/9? Doesn't matter if this is a decimal or a fraction, same thing. Just make sure this time it's inverse cosine. You don't even have to do this in 2 steps, everybody, all at once. Just like all of these. I didn't have to do cosine of 306 and then do 1 divided by that and copy a bunch of numbers. Pretty much any calculator now can do all that in one move. 1 divided by cosine 306, enter, there's your answer. Here, inverse cosine 2 divided by 9, enter. Oops, I'm sorry, that was cosine. Inverse cosine, sorry about that. I knew that was wrong because that just didn't seem right. Now, that's certainly much better. An angle, 77.1. So that would be 77 degrees. Okay. So just some basic calculator work. So now we can start looking at some full word problems. So we'll do a couple. There's certainly a nice bunch in the book. As always, right, everything we do in the videos, you should also be going through all the examples, all the practice in the book. It's what it takes, everybody. It's nice to be able to follow along through the video and say, I get it. but you really get it when you can go through and do it yourself. So make sure you get plenty of practice through all this. So let's start off with this problem. Number 1. Let's say we have a tall building and we want to know the height. If you stand 110 feet from the front door, the angle of inclination from you to the top of the building the angle of inclination from you to the top of the building is 72 degrees. To the nearest whole foot, how tall is the building? So, how do we do this? Well, a word problem. We could always start off by drawing a good picture to get ourselves started here. So let's think about, here's our tall building. Now here's where in word problems, in math, not just here, in most math classes, we make some basic assumptions. So when we look at how is the building, without any extra information, how does that building hit the ground? Well, we assume we build buildings straight up out of the ground. So therefore, our regular ground, our sidewalk, etc., that would make a right angle with the building itself. Here you are. You're 110 feet away from the front door, and the angle of inclination from you to the top of the building. So there is no ladder or anything here. That's just a make-believe line. But by filling in that make-believe line, notice we've got a nice right triangle. We know this angle is 72 degrees. We want to know how tall is the building. So in essence, we want to know what is this side length in our right triangle. Now, some people, before we get to doing these problems, I already really wanted to get to the word problems themselves, so we draw these pictures. But some people, they like to just have that picture kind of already set up to get this practice. I think it's worth to just do it all at once. So now that we have that established, how do we get this side? Well, let me point out first thing what we cannot do. And what we cannot do is use Pythagorean theorem here. People go 72 squared plus 110 squared, and they do all kinds of things like that. That's nonsense, everybody. Pythagorean theorem are the 3 side lengths. It does nothing to do with what the angle measurement is. I mean, the angle measurement is connected through the side lengths, but that is not a part of the Pythagorean theorem equation. What we should be establishing is that we have, this is the angle we know, so there's my theta, and from theta's perspective, I know this side, which is the adjacent. I want this side, which is the opposite. Which trig function connects the dot between opposite and adjacent? It's tangent. Tangent of theta is opposite over adjacent. Well, in this problem, we know theta is 72 degrees. We want the opposite, and we have the adjacent. We finish solving this. We multiply by 110. Some people look at this as cross multiplying. That's fine if you look at it that way. But to finish solving for question mark, and again, all at once. We shouldn't need to do this on 2 steps on our calculator. All at once, we'll do 110 times tangent of 72. I'm already in degree mode. 338.5. Again, my rounding directions, even in the problem, to the nearest foot, to the nearest tenth of a foot, we'd use the 4 and say 338.5, but to the nearest whole foot, we use the 5, and we'd say that would be 339 feet. Okay. Now, a few little things. Now some people automatically start saying things like, oh, well, tangent does this, and they take one problem and they try and make these gross, massive generalizations. But what we should take away from this is the idea, get the picture set up. Figure out, what do you know, what do you want? That's the way to put all of this information together. That's the way to solve these types of problems. So let's continue. Let's do several more. Number two,